Welcome everyone. In this video, I want to go over mathematical induction. So let's go over the definition first. Mathematical induction is used to prove that an identity is true for all valid or are valid for all natural numbers greater than or equal to 1, or n is greater than or equal to 1. Now there's some steps to prove by using induction. So let's go over those. So when you want to prove an identity by using induction, the first step is show that the relation is true for k equals to 1, or sometimes k equals to 2 if you're dealing with matrices. Then step number 2, you suppose it's true for k equals to n minus 1, and that's called the inductive supposition. Then by using step 2, you show or prove using the supposition, or step 2, I put it here, the relation is true for k equals to n. To remember this, just remember the 3 S's. So the first one is show, the second one is suppose, and the third one is show again. So let's go over an example, see how this works. So given that we have a matrix A and the inverse exists, we want to prove that a to the power of k inverse is the same thing as a inverse to the power of k. Now we proved this, I proved this in the last lecture, but in this lecture we're gonna use induction, and in my next lectures you're gonna see a lot of induction too. So let's see how it works. We're gonna start with step number 1, show it's true for k equals to 1 or k equals to 2. I used both here. So if you put 1 here, this is just a, so you get a inverse equals on both sides. You substitute 1 here and 1 here, so a inverse becomes a inverse, so that checks. Even if you put 2, so here you get a squared inverse, and the question is that equal to a inverse squared? A squared inverse, that means that's a times a inverse, and a inverse squared is a inverse times a inverse. But how can we write a times a inverse? Remember, we had this property of matrices. AB inverse is the same thing as B inverse times A inverse. So we can write that as A inverse times A inverse, and that becomes A inverse squared. So that checks also. Now we're gonna suppose step number 2, that it's true for k equals to n minus 1. So basically, instead of k, you substitute n minus 1, and i.e. you say this is true. We're going to use this part, assuming it's true, in the third step. Show it's true for k equals to 1. That means you want to show that a to the power of n inverse is the same as a inverse to the power of n, using step number 2. So let's go over this. Let's see what happens. So you write a to the power of n inverse equals to a. Well, first you start with the right side. Now this can be written as a times a to the power of n minus 1. It's like using rules of exponent. A to the power of k is a to the power of 1 times a to the power of k1. So you know, if you multiply, you add the exponent, and you get that. Basically, if you take 1 out, then you write this as k minus 1. So that we can use the same thing with matrices. So we start with that. A n inverse. So now if we go over this, we know we have this property of matrices or inverses. A times a to the power of n minus 1 inverse can be written as a to the power of n minus 1 inverse times a inverse, by just using that. So now we know that this is true. we can change the notation for this by using that. So therefore, instead of a to the power of n minus 1 inverse, we can write a inverse to the power of n minus 1 because, and I put here, this is from step 2. And then this continues, we don't change that. So now once we have that, a inverse to the power of n minus 1 times a inverse to the power of 1, when you multiply, you add the exponents, and I put it here. So if we add the exponents here, so we get a inverse to the power of n minus 1 plus 1. So you know this to cancel. So you get a inverse, a to the power of n inverse equals to a inverse to the power of n. And guess what? This is what we were looking at. So what we did, we used that, suppose that is true, and in this step we used it, and we proved at the end we got to our statement or equality, and it worked out. Now in the next lectures we're going to see more inductions, but just try to remember again these 3 steps. Show for k equals to 1 or k equals to 2. Second step is suppose is true for k equals to n minus 1. So you substitute k by n minus 1. That's the inductive supposition. And supposing the second step is true, you prove the main equality or the statement at step number 3. Thank you for watching, and I'll see you in my next video. Have a good one, everyone.